I'm Yvon Maday, and I will start to present you this CEMRACS session for this summer on quantum computing. So first of all, all my slides are in French, but I will speak in English. So what is CEMRACS? CEMRACS is a summer school during that takes place in Marseille, Lumini, and the objective is to have an international summer school organized for 6 weeks. And we are already close to 30 years, and it's organized at CIRM, close to Marseille, close to the celebrated Calanque in the Marseille region. Okay, so this summer, the CEMRACS will be dedicated to quantum information, quantum computing, with a particular focus on 2 scientific domains, which are the scientific computation and the cryptography. First of all, maybe let me remind you what is the CEMRACS that was organized in 1996 with Frédéric Coquel and myself. And so since then, we have every year a session, which are all at CIRM. And the first phase is a school where we speak about the subject. The subject each year is different. And it's good to have courses, lesson, teaching for the first school, so that everybody, specialist or not, will have a basic background on the theme. And the second part of the school is dedicated to a smaller number of people attending, that they will stay during 5 weeks at CIRM, and will work intensively on projects that are proposed by different entities, and mainly from industries, and some of them from academia. So each project proposed by an industrial partner or an academic team is dedicated to the subject of importance, and this year it will be quantum computing, and it is given to a team of 2 or 3 people, young people, for which it may be a first way to go out from their PhD program. So generally they are during their PhD or after the PhD, they are in postdoc or looking for a postdoc. And this is a sufficiently long period so that they can work together on the project, and maybe after this intense period of 5 weeks, they will continue to work, and at the end, maybe there will be, and often it is the case, there is a publication on the subject. So each year, each day also, there is a seminar which is given either by the participant to tell at which stage they are in their research in the project that has been given to them, maybe explain what are the difficulties, so that the whole group can think about the difficulty, maybe suggest different ways to go, different solutions, and everything is tested during this 5 weeks intense research period. So maybe you can ask why the CEMRACS, okay? So the reason is this, the iCase. iCase was for me, when I was a little bit younger, a first way to spend the summer and do research in a framework which was very intensive, but very nice also. This was in a NASA research center, and it has been settled by these people, the motley crew, as it is written, where we see here David Gottlieb, and here Stan Osher, that some of you may know, and there are other people, Bram van Leer, for instance. This was in summer 1982. Actually, so there are numerous centers to attract young researchers during the summer in United States, and this is another possibility to go and spend at ICERM in Rhode Island, in Providence, where there are very nice facilities and where they organize maybe summer retreats. And the question I had at this time was, why shouldn't this be in France or in Europe? Okay. And actually, we proposed with Frédéric Coquel in 1996 a first theme on the coupling of equation. And then every year there was a different subject. So the first year it was shape optimization, adaptivity, numerical approximation of complex flows, environment, etc., etc. And actually, at the beginning, it was really friendly, and it was also an opportunity to open the CIRM, the Center of Mathematical Research and Meetings in close to Marseille, that we will see later. And actually, it was closed during the summer. So at this period, it was very weird to organize something during the summer in France, and more weird to organize it also in Marseille. And actually, the first year, the newspaper came and see us, and we explained them what we wanted to do during the CEMRACS during the summer. And there was a subject that was in the newspaper, the local newspaper, which was the athletes of the cybernetic cogitation. So this was the first one at the end that was dedicated. So it was very friendly, because people are most of the time very young, as I told you, during their PhD or at the end of the PhD. And the follow-up, it continues until now, 2023. Last year, there was no due to Olympic Games, but this year it starts over with the subject of the quantum computing. So maybe we can see now a little bit about the place where it is and why it is important that it is in this region. So here you see roughly, and with a close-up, you see where the CIRM, Centre International de Rencontres Mathématiques, is located. And you see that this is a very nice place, especially during the summer. And actually, it's not a site, it is un écrin. Je ne sais même pas comment on dit ça en anglais. Okay, so you can see some pictures here. It is in an old mansion, which was given at the mathematical community. And it is a place where people can stay from the entire world for a long period. Actually, 6 weeks is quite long. But you see that it is very nice. And there are nice places to work, big blackboards on which you can write with chalks, and it's very important to do mathematics and to do research to have this facility. Okay, you can see also that we can have boards outside and to discuss. Of course, if you spend 5 to 6 weeks, it's important also to enjoy about the site. Here you see some calanques, and you have a wonderful sightseeing. You can do some sports, of course. And what is important is that you can speak together. You can speak during the breakfast. You can speak during the breaks. You can speak during lunch. And it's very important because young people can meet older people, senior people, that they would never think about speaking. They would never dare about speaking, and to meet them and to expose them what are their problems, what they are willing to do. And maybe it will be a way also to continue a collaboration later and to have a postdoc with them. So it is important to have this atmosphere, which is very enjoyable, but where people work a lot. They start at 9 and they continue during the night. As you can see here on this, they can continue to discuss about their project. And of course, because life is not only to work on these projects, they are relaxing time where people can enjoy and have a wonderful bouillabaisse. So the reason why it is possible to have it in France, and the aim of the CEMRACS is to promote research in mathematics and in computer science and present the news, invention, and transform them in innovations. The format is to have people that be staying for a quite long period of researcher from different various horizons, either industrial or academia, but that may be working in different fields of mathematics or computer science. In order to realize these things that make invention become an innovation. And by doing this, CEMRACS allows meetings, new meetings, in a special frame, in a time-space unusual frame, and allows to initiate collaboration that can last for a long time. In time, young people will meet young people, and they will continue to be in contact later. And this is during these almost 30 years of existence of the CEMRACS, it is something that can be seen, and also young people meeting senior people, and this way making a new direction in their career. So the idea of quantum computing is that it is important to do so because we will first give a training to the students to the way of programming on a quantum computer, and also look at different algorithms that go from number theory, factorization, phase estimation, and the solution of linear systems. There will be also things on quantum error correction, and it will be focused on the ability of using this computer to solve problems that are classical in scientific computing, solving partial differential equation, and also quantum cryptography, in order to look at the efficiency of quantum algorithm for cryptography and look for the post-quantum era. The main point is that the step in order to be able to understand how to program on quantum computers is that the step is very, very high, and there is a smaller distance between these two different domains that generally don't go together much. There is a smaller distance between these two domains, which is the distance is much smaller than the two ways of programming on classical computer and on quantum computer. So the idea to have these two communities to speak together will be that they will be able to propose new ways of using the quantum computer. Okay, maybe Ludovic, it's yours.
Yeah, so just to continue on the motivation and why having a CEMRACS dedicated to quantum. So the first things to mention is that maybe when you heard about quantum, you believe it's science fiction. So it's not science fiction at all. Now we have devices which are more and more powerful and which can be even accessed online. So no, it's a reality. And so the other aspect is that quantum computer will offer speed up on certain certain problems that cannot achieved by classical computer. And so in particular for crypto, the impact is somewhat negative, because we know that if we have a quantum computer which is powerful enough, then we will be able to break all the public key standards which are deployed today and which protect our communication. So that's kind of negative impact, but to mitigate that, so we are currently deploying a new generation of cryptography, and which will be the topic of the summer school and maybe some projects which are post-quantum and quantum cryptography. And so you will have some courses dedicated on that. And the other aspect, so this is negative in some sense, but what is behind that is that you have no new algorithmic paradigm that can be exploited to maybe do different things and solve differently the problems that we have in crypto. And in fact, the building blocks that we are using in scientific computing and in cryptography are quite similar. So that's why we decided, and we are also moving in this direction recently. So that's why it makes sense to co-organize, to have the two topics for this CEMRACS. I think I'm done, Yvon.
Okay. So the impact of quantum computing on numerical simulation is, as Ludovic said, the acceleration of the computation with the exponential possibility to solve a complex set of equations, the efficiency of the algorithm in order to reduce the complexity from O of n to O of log of n, and the application to different fields of physics, quantum physics, fluid dynamics, and climate modeling. So maybe some algorithms that are already implemented in order to solve partial differential equation and to do numerical simulation are the HHL algorithms, the quantum Fourier transform, quantum walk algorithms, the variational quantum algorithm, in particular in order to solve eigenvalue problems, the lattice-Boltzmann quantum method, quantum phase estimates, and quantum Monte Carlo. Okay, so the program, as was already said, which is since quite a long time now, about 20 years, co-organized by SMI, la Société de Mathématiques Appliquées et Industrielles, is the connection with a strong industrial partnership with two sequences, the week and the hackathon part, okay? And so during this, so here you have the dates, July 15 to 19, where there is this courses that we will explain now, and the 5 weeks of hackathon from July 21 to August 22. So during, as I said already, during the second phase, each participant will work in a special team on a project, which is a collaborative project, which is proposed by some partnership industries or academia team. So each team is composed of 2 or 3 young researchers and 1 or 2 senior researchers that are proposed by the company or by the academic team that have proposed the subject. So the program of the course is as follows. And so this is the wonderful seminar room in which the courses are given. And Ludovic, maybe you can speak about the courses that are given in your discipline.
So as mentioned before, so there is something specific for cryptography, which is the impact on new standards. And to deploy a new generation of infrastructure, we need alternative to what we use so far based on factoring on our discrete logarithms. So we need to renew our standards. And for that, you have 2 directions. So one direction is so-called post-quantum cryptography, and it's very similar to the cryptography which is used today. The only difference is that you are going to use a new harder problem in the sense of quantum. And so Pierre-Alain Fook will speak about that. Another direction, which looks a bit surprising, is that you can also use quantum to protect communication. So this is called quantum cryptography, and in particular, you can exchange key with quantum key distribution with a level of security which is even better than what we have with post-quantum scheme, but we have very strong practical limits. That's why it's still a bit on the research part, but still very interesting. So that's for the design point of view, protecting communication, but from the algorithmic part, as a cryptographer, and we always want to investigate the security of primitive. And for doing that, we are happy to use any types of algorithm in the classical and quantum setting. And so all the paradigms, the type of algorithm for which we have speed up in the quantum setting, like HHL, variational algorithm, it's something that are used also in the context of cryptography. And so you will see also this different facets through the course of Pierre-Alain, but all the other courses we are going to be related for that will be also useful for someone in cryptography. And that's from an algorithmic part. And also another feature of the school is that at this stage, if you want to be efficient, it's not completely sufficient to use the algorithm in black box. And so you still need to be a bit closer to the device and to understand what is happening. And in particular, you have error correction. You need to take care of that. And so some course will be dedicated to that. So typically the course from Gilles Zemmour.
Okay, thank you. And so now I will present rapidly the program for the courses that are more related to numerical simulation. So the first one is paradigm for different technologies, algorithm on different technologies given by Thomas Herral. And so he will present as an introduction the main algorithm used on quantum algorithm that nowadays are noisy and speak also about the fault tolerant of the current computer. So he will introduce some of the algorithms that I told you about before, in particular the Fourier transform in the quantum work and the use of it in order to have a quantum phase estimate. He will speak about the Shor algorithm, which is well known for factorization, and also speak about the estimate of the energy in quantum physics. Because he will be speaking about the current technology, he will introduce also some aspects related to the decoherence on the quantum computers, and he will justify the idea of the variational algorithm in order to diminish the side effects of these difficulties of the current computers. And in particular, he will speak about the variational quantum eigensolver. There will be a hands-on part on his course, related to his course, so that the student can understand more what about them. The next one will given by Yassine Hamoudi, will speak about a different optimization problem solved on quantum algorithm. This type of problem optimization has been looked for at the very beginning on the quantum computer era. This computer can be either inspired by physics, like adiabatic algorithm, variational algorithm, QAOA, quantum annealing, etc. And also, it will present some quantum algorithm based on convex optimization and also on combinatoric optimization. The next course will be about the Schrödingerization. Because one of the main domain of application is to solve the Schrödinger equation, and this dates back to Feynman that said that if there is a problem that should be solved on quantum computer, this is the one to be done, and the Schrödinger equation. And due to this, it is interesting to consider different types of problem in another way, to expose it in a higher dimension, to set it in a higher dimension, and transform any problem in like a Schrödinger equation. And so Nana Liu and Shijin have introduced this way of transforming problems into problems that can be solved directly on quantum computer. And in this course, Nana Liu will present the way to do this, and the way also to implement it. And some projects later will be given on this Schrödingerization. With Agnieszka Midlar, now we will go to the resolution of large problems in linear algebra, and problems set in high dimensions. And the way to solve this problem with differential equation, either linear or nonlinear in high dimension, based on the possibility given by a quantum computer. So she will speak about block encoding and linear combination of units. The last course that I want to present is the one given by Maziar Miraimi, who is very close to the building of this computer. And in order to be able to work on this computer, you have to control and to have fault-tolerant processors, and that are able to avoid all the difficulties that are on the current generation. So Maziar will present the different approaches in this direction, with the error correction on the qubits, and different ways in order to improve the building and the use of this computer. After this course, there is the 5-week period, which actually is the most important. The first one is very important in order to understand the basics of the quantum computing, but the aim of the CEMRACS is to work on these different projects. Without the collaboration with companies, it would be useless. There is no meaning to do a CEMRACS if there is only academia projects. So it has to go within the frame of industries and companies, and this is the reason why we are looking for industrial partners that propose projects that are given to the student and to the team that will be there during the 5 weeks. 5 weeks is both short and long. So it's short because things will not be finished in 5 weeks, but there will be enough time in order that people speak together, try things that don't work, explain why it is not working, and try to find with the connection with everybody, try to find new ways, new direction in order to solve the problem. And after these almost 30 years of existence, we can certify that almost all the projects have really benefited from this 5-week period, and the difficult problem have been maybe not completely solved, but at least clarified after the 5 weeks. And the collaboration continues after. And if people want to continue, they can. It will not be done in the real frame of CIRM, but they can continue to work because during 5 weeks they have been working all together, days and night and days, every day in the week if they want, even though they can go into the calanque and have a swim, even though they can do ping pong, even though they can do other things, but they will spend 5 weeks working on this subject, and this is generally felt as a very, very, very encouraging and very enthusiasm. A lot of enthusiasm in the team. So these projects, some of them, most of them being given by companies, the list is not finished, but there are already some projects that we can propose. And Ludovic will speak about the first one, the protocol and cryptography, hybrid cryptography in post-quantic and quantum. Ludovic, à toi.
Yeah, exactly. So the first project will be about combining the advantage of post-quantum and quantum cryptography. So you will learn with the talk of Mina that you can exchange key with a very good security level using quantum technologies. But you have some practical limits because you need to send quantum information through a channel, and with the technologies that we have today, we cannot do this over a long distance. So it's quite limited. And so think about communication today. So you want to connect a point from France to everywhere, or from the US to China, and so on. So these distance limits of quantum key distribution is a strong limit. So what we want to investigate is how we can somewhat combine quantum key distribution with post-quantum cryptography, in some sense, to make post-quantum cryptography slightly stronger and make quantum cryptography slightly more usable. And so for that, we will start from recent papers on combining both technologies, and the project will be as follows. So one of the goals is to implement some protocols that are on the literature. In this project, you are going to do software developments. So the goal is to develop, well, to have the software and to test several options to compare these protocols and to understand which one is the better. So you will have a software development part. The second part will be about to, well, try to push the state of the art. So once you will have a good idea of what are the protocols, so you implement it and you tested it. The second challenge will be to try to improve that. So of course, we will guide you. We have some ideas to improve. And so in this improvement, the goal is not only to propose something which is functional, which is working. Something which is also very important is to provide security proof. So I'm kind of sure that in this project, we will manage to have different type of combining these building blocks. We'll be able to think about new protocols, but what is going to be a bit more challenging is to try to really prove the security of this protocol. So you will combine in this project software developments for quantum and post-quantum. So we will use, you are not going to develop everything from scratch. So some building blocks are already available. So more or less, your job will be to combine some existing tools, and after you will also have some more research part to improve protocols.
Okay. So now I will present the few next projects. First of all, let's speak about the IFPEN, Institut Français du Pétrole, Petroleum and New Energies company, which present a problem related to the mobility optimization. So the idea is to optimize the placement of infrastructure of, for instance, for battery charging, the size of the battery for electronic cars, and also the way to reduce the energetic consumption for different types of itineraries for different types of vehicle. So it will be a graph optimization that this company is willing to test and to see if on quantum computers the exponential acceleration of the process can bring something to this difficult problem. La Poste, where here also it's a supply problem, where they want to optimize the moving of different containers that are supposed to contain mail, parcels and letters and things like this that La Poste, the postal office in France, is supposed to bring. So that is a very difficult problem because they are different containers, and some of the containers may be empty when traveling from one place to the other. Some may be too full, and the problem is to try to optimize the moving of these containers. The problem proposed by L'Oréal, because I work it, is a way to optimize the genome analysis. So the idea is to use a quantum computer in order to propose new algorithm, in order to be able to have de novo assembly of genome from different fragments obtained by different reads of sequencing analysis. So the idea is that with sequencing, you are only able to have short reads of DNA, and the problem is to recompose the global genome that is of interest for this company, in order to have analysis on the skin, on the hair of people. The next project given by ONERA is related to the course of an NLU on Schrödingerization, and what they want to do is to look at the difficult problem of hyperbolic system of conservation laws, where the Schrödingerization is different from what is given for parabolic problem, and they want to analyze what is given on this type of problems on a first test, and maybe look at what the Schrödingerization is able to propose as a new scheme, new resolution scheme on quantum computers. The subject proposed by Thales is on quantic convolution, group quantic convolution for partial differential equation, where the idea is to use this type of problems, group convolution, in order to solve a linear partial differential equation in the case where you have some symmetries. And so the idea is to consider this with a tool given by a team at MIT of Seth Lloyd and University of Waterloo, where the complexity of the algorithm does not depend on the sparsity of the matrix, but more on its geometric characterization. So for this problem, it is expected also to have polynomial acceleration with respect to the dimension of the problem. The two next projects are given in the frame of European Research Council activity based on quantum chemistry, and the two are in different directions. The first one is the way to consider the ansatz for post-Hartree-Fock representation dedicated to the implementation on quantum computers. So as I told you, the step between classical computers and quantum computers is huge. And one of the things is that that can be said is that quantum computers can do only things related to unitary transforms. And due to this, we have to think differently on the way the problem is set, and in particular in this resolution of post-quantum hybrid formulation. You have to think of different ways to set the problem, and the ansatz is interesting to understand, both dictated by the way you have to program the quantum computers and the problem you want to solve. The second one is that for many problems, the iteration will, when you want to minimize an energy, which is often the case for problems in quantum chemistry, you arrive to a stationarity. The problem is well known as a Barren plateau, and a bunch of authors have tried to understand why the Barren plateaus are rising. And one of the reasons is that you have a global problem of optimization. So the idea would be to decompose a little bit like what you do in subdomain analysis, subdomain decomposition, to try to decompose the global task into a series of local tasks, and in order to avoid the Barren plateau. Okay, so let's end and open to the question that you may have. So the CEMRACS computing is to be organized this summer, and we need you. We is the organizing committee composed of Karim Azoum at Terratech, Igor Cholet at University Paris Nord, Guillaume Delay at Jacques Williams Laboratory, with Missang Dupuis, Benoît Fabrège at Université de Lyon, Cindy Guichard at Sorbonne University also, Marie Landpinsma at Terratech, Ludovic Perret that you heard at EPITA, Marie Postel, who is the president of the organizing committee at Sorbonne University Laboratoire Jacques Williams, Olivier Roata, who is online also at the University of Limoges, and Pascal Tremblin at la Maison de la Simulation at CEA. And the scientific committee is composed of Eric Cancès, Shijin, Elam Kashefi, Tanja Lange, Lin Lin, myself, and Soro Suchi. So thanks for your attention, and now it's time for questions and comments if you have. Okay, so
Yvon, perhaps I'm going to start with a short question to help all the attendees. So my question is really simple. I have a challenges. I'm an industrial. How can I propose my challenges and what I have to do for that?
okay, so thank you for the question. I cannot answer, but maybe it's more the subject of the organizing committee, so somebody can answer.
Yes, so it's very simple. You just have to contact us at the email address CEMRACS25.smy and so on. I don't remember the exact address, but you have it on the website. I don't know if it's clear enough. And there is a document to fulfill, but you just have to ask by email and discuss by email, and then we will just discuss about how to do it.
Now, maybe to give the big lines. So first you have a project, okay? So the project, a priori, you don't know how to solve it. You have an idea and you would like to use quantum computer to do so. So you have a team in your company that may not know about how to do, but know the project, know what is the outcome you are looking for. So what you will have to do at some point, but first of all, please contact us, will be to be able to write something about the description of the project, why you think that quantum computer may help, what maybe the algorithm you want to use can be written, and also if people in your company, in your group, will be able to come, okay? Because of course the team cannot work if there is no, during these 5 weeks, continuum explanation, say exactly in which direction you are doing. So you don't have to come all time during these 5 weeks, but you have to be available at least sometime during these 5 weeks and regularly, in order to that the people that we will find and to put on your project will be able to do. Of course, because the project is yours, and we are organizing, we need a little bit of money to do so. So there is a cost, which is about, combien c'est 15,000 euros in order to support each project, to support the venue of 2 young students, and so the housing and everything which is required during these 6 weeks of attendance, the first week of the course and the 5 weeks of the hackathon.
Thank you, Yvon. We have also a question from Massinissa Zenia. I'm a PhD student. What's the application procedure?
Okay, so the question is, I'm a PhD student. What's the application procedure? So the procedure to fulfill is on the website. You have to enter some personal data just to create an account on the website. And then when you log in on the website, you can open a registration procedure. There are 2 types, well, there are 3 types of registrations. First one would be if you want to attend the summer school on site. Second possibility is to attend the summer school by Visio online. And the third possibility would be to apply for the hackathon session of 5 weeks, and also attending the summer school. In case you attend in case you apply for the hackathon and you are selected, then CEMRACS just covers all expenses related to housing and meals, and you just have to pay for the travel between your place and the CEMRACS place. I don't know if it's clear enough or if you have additional questions.
Thank you, Guillaume. Guillaume, Perhaps you have two other questions. I think I don't know if you can answer directly to the two questions.
Yes, I guess. So the second one is, sorry if this was already mentioned and I missed it, but is the hackathon open to everyone or just for students? The idea is that hackathon will be open more for young people. By young, we mean that people that are in a PhD thesis, that are doing a postdoc, or that have been recruited, I mean, that are a permanent position for only a few years or one or 2 years, let's say. So it's more for young people. Second question was, so 15K are given from CIRCAM to the research institute company to support the attendance. I'm not sure to understand. The idea is that the company that proposed the project, we expect the company to finance it. And basically, most of the cost is to pay for the housing and the meals of the young researcher that will work on the project. So that's the way it is, in order that it is free for the people that take part to the hackathon. We need that the companies finance those expenses. There was also another question that we missed, I think. For research center or companies, there is some financial support for travel and expenses. The financial support that we provide is related to people that, as I said, take part to the hackathon. We just cover all their expenses on site. I mean, housing and meals. But they still have to find a way for travel. And there is also, I just think, there is also another help for application. There are 3 grants for international students that could come in Marseille for the hackathon. Those 3 grants are given by the SIMPA. Maybe if someone has the link, can just give it in the chat. So the SIMPA will just give 3 grants for the full hackathon and summer school. And the grant will cover, I think, the stay. There will be some money, I think is 10 or 20 euros per day. I don't remember. There's some more money to spend on site. And I think also they cover the travel for international students. I'm not really sure on that point. Yes, thank you for the link. I think it's written there. It's the one in French. There is also another one in English. Yes, the travel expenses are covered with a maximum of 1,600 euros, visa included. So I don't know if there are other questions.
Of course, if you want, you can open your mic and ask your question, but you can write it if wanted.
Maybe a point on confidentiality during the time people think about this possible question. So, of course, when you deal with industry, there is often a problem of confidentiality. It is not really the frame of CEMRACS to have a problem of confidentiality, but this can be dealt. So, first of things, the very true problem of the company maybe not the one on which people will work during CEMRACS. It can be a denaturated problem, it can be a similar problem, but not with the data of the company. Maybe during these 5 weeks, the idea will be to work on a toy problem, on a similar problem, but not on the one that is really of interest for the company, so that the first projects, the first ideas can be tested and the solution can come. And then in the company, people that have participated to the project during these 5 weeks can go back with a lot of experience, and this will be then they will be able to continue on their particular problem for which there is a confidentiality. The idea of the CEMRACS is really that the problem are presented into the whole crew so that a new solution can arrive. So this is really the positive aspect, and this is really the way it works. By opening the problem to everybody, you can benefit of the knowledge of everybody. So during this session, like in the one that were arriving every day, the last years, then there will be people that are working directly on the project. There are also people that will come for 1 week, maybe 2 days, maybe 2 weeks during the 5-week period, that are interested to the team to the theme of the CEMRACS, that want to work on computer, that have new ideas. They will come on their own funding. They will pay to come, okay? But they will be able to discuss with the people that are working in the team on the different projects, and maybe allow them to have new ideas that otherwise they wouldn't have got. Okay, so this, the fact that it is open is really an important thing, and it's really a positive aspect. Difficult to combine with confidentiality, but not so much actually, if you think a little bit of modifying somehow the project on which you are working, and the one that you will be proposing for CEMRACS.
Thank you, Yvon. I have a question. Perhaps it's going also to help the attendees. Is it possible to share a challenge or project between 2 companies? You know, I'm talking about sharing the price of the 15,000 euro, and if I found like a company who have the same problem they want to solve, is it possible to do that?
Not only it is possible, but I think it's very interesting, because this way to have the collaboration between different companies in order to solve a problem is a reason for richness. So I think it's really a way to collaborate all together, and if 2-3 companies have the same goal on this difficult problem of how to use quantum computers in order to solve their problem, this will be very positive, I think. Okay, and this will be less expensive also, even though 15,000 is not a huge amount. We understand that in these difficult days, it may be more simple to find 5,000 euros. So of course, if you want to collaborate, and this is really a motto of CEMRACS, please do so.
And the last question I have, Yvon, for you, we are talking about company who want to propose project or challenges, but what's the definition of company? It can be also an academic,
yes,
and an industrial, for example, the both, 2 industrial, 2 academics. Everything is okay?
Everything is okay. As I showed, and Ludovic also, there are 3 projects that are proposed coming from academia and the other coming from companies. And some projects, in particular, if they are related to a PhD student that is working in the company, generally the student has an academia as for the thesis supervision, one in academia and one in industry. And of course, they can propose together a project.
Perfect. Thank you very much. Do you have other question? We don't have more question.
It seems that it was clear enough.
Yeah. Yeah.
So we are looking for your applications. Yes, I have one. Okay. Open your mic.
Yeah, Fikri, you can open your mic if you want.
I can't. Okay.
Oh.
So maybe you can write it. In the meantime, if other participants have questions, do not hesitate.
Hear me?
Yes.
Yeah.
Yes, I am Figrafit from RT. The question I have is the following: as a lot of enterprise, we want to see what can quantum computing bring us. So we have not a specific problem, but we have we have kind of problem like in optimization, numerical simulation. Well, it's we can formalize a problem and we cannot formalize a specific problem. We just want to know what can quantum computing bring us regarding specific problems. Can we have something like general formulation of our problem, and we choose with the committee which one is suitable, or we have to be specific in our problem, for example?
No. Okay. So two answers. If you have time, you can contact us and we can have a Zoom meeting beforehand in order to help you, to tell you what is possible, what we think is possible, and we can think a little bit. It's what we did with some of the companies that have already proposed a project. So you tell us what you want to do. We can have a look to what is available and discuss a little bit. You can come to see us in particular at Sorbonne University, where every 2 weeks we have a Groupe de Travail, a workshop in which we present some of the algorithm, and it's really a Groupe de Travail, meaning that we are learning all together. We propose new things, and we can review, discuss about what could be suitable for a project. So this is the first and I think most interesting question. The other things would be to participate only to the first week in which you will have the presentation of everything that can be done on a quantum computer with experts that will give the courses and give the hands-on and sessions, and this way you can during this week period have a better understanding of what can be done. Of course, if you want really to benefit about the CEMRACS, which is the 1 week summer school and the 5 weeks hackathon, please come and discuss with us.
I'll do so, because we have 2 points. The first is it's the beginning of our journey in quantum computing at RT. So we need to gain some expertise in the field. So definitely we are assisting to the first week of courses, and we were asking if we can propose something, but we have not expertise in our department regarding quantum computing.
Yeah, very few companies actually have the expertise for the moment. They have problems, they have a little bit of knowledge, thinking, and they want to see more. Discussing with us about writing a collaborative project is certainly something which is possible.
Okay, clear for me. Thank you very much. So we will keep in touch, and I will send an email to you, Yvon, or CEMRACS.
No. Write to CEMRACS 2025. The mail that was given.
Okay.
But you can write me. You can write me if you don't find it. No, don't.
Oh yeah, I have the email. Thank you.
More question? Is it possible to have only the summer school? I know the answer, but perhaps Guillaume, you can give the answer.
Yes, of course. The hackathon is only targeted for young people. And if you can go to the summer school, whether or not you are young, it's not the problem. It's just that you need to be at the summer school in order to go to the hackathon, but the reverse is not true. You do not need to go to the hackathon to follow the summer school. And as I said before, the summer school can be followed on site or online, as you prefer. I think it's answered the question.
Thank you very much.
Yeah.
By the way, all the info are on the website, I think. And if you have any other question later, feel free to contact us using the address that we shared in the chat.
Okay. So if no more question, Yvon, perhaps we can close this webinar. What do you think?
Absolutely. If there is no more question, we can thank you for listening to us, sharing some ideas, and do not hesitate to contact us if you have questions, so you can participate only to the course. If you have already an experience on quantum computer, you can also come during the hackathon period, because as I said, we have people that will be working on the project, but we also are very willing to have people coming on their own funds for maybe 1 week, 2 weeks, in order to discuss with us about some of the projects, because the collaboration and the exchange of ideas is really positive. And having organized the 3 first one, I remember that it was dense, but it was very rich. And at the end, I knew much more things than when I arrived. So thank you, and so we'll be in touch.
Thank you, Yvon. Thank you, Guillaume. Thank you, Ludovic. And don't forget, the registration is open. If you want to send us some challenges, don't hesitate. We are here to support you. So thank you for all the attendees. Thank you very much, and hope to see you in Marseille.
Okay.
Bye-bye.
Bye-bye.